My name is Stacey, and I'm a director with Oracle's database product management team. And I'm going to talk to you today about deploying an Oracle database in a Docker container. And I realize there are some people who may not be in the room, but for those of you in the room, who here would classify themselves as a database administrator? Anyone? Okay, a few of you. Who here would classify yourselves as a developer, as a programmer? A few people. And who here is using Docker today? Okay, I see Chris down there. Excellent. One other question. Actually, no, I'll wait till we get there. So, having said all of that, everyone from Oracle is obliged to put up a safe harbor statement, and that's primarily because some of the things I'll talk about, or I may talk about, may be about future rollouts or features and functionality that may not be available when you go to use this tomorrow, for example. I may talk about things that are coming soon, and just to indemnify myself, so to speak, or to ensure that anything I say may not be misconstrued, we always have to put this safe harbor statement up. But at the end of the day, when it comes to running any Oracle software, all the answers you need in terms of availability, support models, etc., is all available online. I'll talk about some of our support policies when it comes to running the Oracle database on Docker, and I do recommend you have a look at those items. This is one of those presentations that has many more slides than I'll be able to get through. The idea being that I will share it with you all after this session, and you'll have all the commands and the syntax for various things that I'll be demonstrating. And the goal here is to do a live demonstration as well, just to show you how easy it is to perform many of these operations. So I've got a very quick overview on Docker, for those of you who may not be too familiar with it. I'll then talk about Oracle and Docker, and that's not just Oracle database, but just Oracle's stance and what Oracle is providing in this space. And then I'll go through deploying an Oracle database on Docker, and then I'll have a bit of a discussion of the different services we have to run Oracle and Docker in the Oracle Cloud. So a really brief overview. What is Docker? Well, it's a software container platform. It started or originated from the Linux containers model. It's available on Windows. If any of you attended the .NET session earlier by Christian Shea, he showed you how to run that. It's available on Mac OS X, and obviously it's available on Linux. And it's available pretty much on all flavors of Linux, and Solaris support will be coming soon. Now, having said that, Solaris has had a containers solution for quite some time now, but it's subtly different from what Docker provides. So when we say it's coming to Solaris, it's more along the lines of being completely native to the Docker offering. Now, getting back to Windows, there's two versions of running Docker on Windows. The first version is if you run it on the pre-Creator Edition, pre-Windows 10 Creator Edition. When you go to run Docker, it will in fact bring up a virtualization layer, and it will bring up a virtualization layer to emulate Linux running on that Windows OS. With Windows 10 Creator Edition on, you can now run native Windows Docker containers, and that was part of Christian's demonstration earlier. Oracle is a part of the Linux Open Container Initiative, which also means that Docker and the container components are part of the open source model. Now, there's two versions of Docker available. There's the commercial edition, or the enterprise edition, and the community edition. And the one that I will be demonstrating is in fact the community edition. Now, I will point out, if you go onto docker.com and look at the editions to download, it will say that Oracle Linux is not supported, or it doesn't list it as one that is supported, and it therefore implies that you need to go with the Enterprise Edition. That indeed is not the case. So if you are interested in deploying the commercial edition, the community edition, and playing on Oracle Linux, as you'll see through this demo, it's very straightforward. So it's an open platform to build, ship, and run distributed applications. I'm not going to dwell too much on this because I think you've heard so much about Docker and Kubernetes today that you probably can speak about this in your sleep. But it's basically, in Docker versus the whole Linux container is what we're talking about here. Docker is an improved version of the Linux container model, the Linux LX. It's easy. There's many components around it, and you'll see this when I run the commands. They're very self-explanatory. It's very simplistic in nature, and it's definitely not complex in what you perform. Many of the components you would expect, like networking and memory and CPU usage, have been extended to just work much more elegantly through the Docker engine, and that's part of the reason why Docker has been so successful and has managed to elevate itself above LXC, or Linux containers. Also, they've done a really good job of providing images that are readily available. You just simply pull them down and deploy them without having to do too much legwork yourself, and I'll demonstrate that for you as well. And because of that, it has been extremely successful in the developer community. Okay, and many consider it as a lightweight virtualization technology, but really it isn't, and this is an important slide to talk about. The second from the left, hypervisor type 2, is what we think of when we think of virtualization, right? We've got like a VMware perhaps running on top of our hardware and our operating system. It could be VMware, it could be VirtualBox, as I'll be demonstrating for you on my system. A hypervisor basically sits on your OS, and then within there, you run additional operating systems with complete software stacks. Now, the benefit of going down that path is those operating systems could be completely different to the host operating system, right? Now, the negative aspect to doing this is that you pay a performance penalty, right? You've got virtualized layers of I/O, of networking, of everything, right? Even video operations. So hypervisor type 1 is along the lines of a Zen hypervisor, right? Where you have the base hardware and the hypervisor runs natively on there, and everything runs as a virtual machine on top of that, and those virtual machines could also be completely separate operating systems, right? Now, if we move to LXC, which is what Docker is an extension of, Linux containers is where you have the hardware and the operating system in this example being Linux, with subsets, or the user space, if you wish, running within that operating system, then gives you this level of isolation, okay? So you've got, in this case, we've got a file called bin.libs on the right-hand side, and you can see that container 1 is inheriting that from the parent operating system, or the operating system it's running on top of. Meanwhile, container 0 is running its own version of bin.libs. It's not necessarily inheriting those components. So it's the user space that differentiates it. Now, in doing this, we're able to run many, many more containers, if you wish, isolated workloads than you could run in a hypervisor, whether it be type 1 or type 2. So it's a much more scalable way of consuming those resources. It's also much more manageable in that you've got this one base operating system, or these tiers or layers in which you can do upgrades, patching, or add components that these containers can inherit, okay? Now, the negative, if it is a negative, is that they are all inheriting that base operating system at the end of the day, okay? Now, Docker is an extension. It's a superset of what the Linux containers provide, and it just provides a much more manageable and a much more seamless way of managing and running these containers, and that's what we'll be looking at. So, container, I've used this term a fair bit. Think of a container, and I've got it written here, a lightweight, standalone, executable piece of software that includes everything to run it on a host. Okay, so all the components required to run this application or this piece of software is self-contained in that container, other than the host components that would be shared across various systems. The Docker engine is very much like the hypervisor in the sense that it's the software that runs those containers. Okay, but it's not the hypervisor in that it doesn't emulate anything. It's simply the host OS that everything is hanging from. And then the image is the image. It's the software components, the binaries, the subdirectories, all the software bits that we are running on top of this operating system. And then we also have this concept of a registry. The registry is where you would host these images. Now, there's several types of registries. You could have a private registry that could be just your images that your business or you are storing and loading and working with. Perhaps you've got a team of DevOps, or developers, I should say, who have this library of images of your specific application components. Meanwhile, there's also public registries. Docker themselves have a registry. GitHub has a registry of components, and then we also have a container registry that you can go to and grab completely self-contained built images to deploy. Okay, and then volumes. Volumes is a subtle thing to get your head around, in that when you run a Docker image or a Docker container, the file system that those Docker containers are going to be pointing to is part of that image. So if you take that image and destroy it or move it or relocate it or do something with it, that base file system goes with it. So that could be a bad thing, right? If you're doing a UAT and you're setting something up, you have to keep that in mind. So when you deploy Docker, you will typically want to point to volumes that are outside of where your containers are running. Okay, and I'll give you an example of that in a moment. So illustrating the registry model here, we can see with Docker, we've got the client, and the client can run certain commands, like a Docker pull, a Docker run. And when we say these commands, we go against the Docker host, where the containers are residing. And if we do a pull command, for example, we go to the registry to grab those images, pull them into our host that we're running on, and actually deploy those images there. Here in this example, we've got an Ubuntu image. The red drum thing is Oracle's icon, if you wish, for pulling down a database. It could be the Oracle RDBMS. It could be MySQL. It could be NoSQL. There are various components that we provide, including a Java engine, for example. The subtle difference I was talking about before is you can also mount or create or pull an image and deploy it to point to a separate volume. And that separate volume would then have persistence, so you can start up and shut down and perform operations on that image without necessarily losing data or state. Okay, and that's important when it comes to dealing with a database. It's subtle, but it's important. So one of the best practices we say for deploying Docker in Oracle is to use a copy on write file system, right? So Btrfs is one example, where it allows you to do snapshot cloning and those operations very effectively and very quickly, right? So you can take a Docker image and deploy it and shut it down and clone it, and without necessarily consuming a larger footprint than you need, but doing it very, very fast. The one caveat to that whole model is that's great for deploying an application or a Java app or something like that, but it's not a best practice for running the database. So when you run the database, there's other modes you will take, and I'll talk a little bit about it when it comes to deploying rack on Docker, which, by the way, we do support. Okay, but I'll get to that in a moment. So containers are non-persistent, right? When you make a change, when you want to roll out a new version of something, you don't necessarily go into your Docker machine and change it there, and that's where you're going to move from. You would typically go in and have a gold version of that image, use that as the central source of where you want your changes to be kept, and destroy other images and replace them with this new one. So that's the model and approach you take when deploying Docker images. And with that being said, when you think of running with a database, that's contrary to how you would want your data to be persisted, right? So that's why it's a little bit different when dealing with a database running on Docker. And I'll talk about some of the things or the nuances that introduces when it makes sense. So yeah, the images are immutable. And yeah, a change to an image does require a completely new image build, right? That's fairly common sense there. Illustrating what I talked about earlier, where these containers are inheriting, or they're hanging or sitting above that base operating system, this slide just helps you understand that. Why is it so popular? Why DevOps and Docker? Well, I think you all get it after hearing some of the sessions today, right? It's extremely lightweight, it's extremely easy to use, and it's very efficient. You'll see, you can pull an image and deploy a database in under 4 minutes, right? Now that's if there are caveats. There's going to be certain architectural decisions you make that are going to impact that, but at the end of the day, you can deploy a system very quickly, okay, and very efficiently. You can run hundreds of containers on a basic Intel machine without having to put in a lot of hardware. It's because of the nature of how the Docker or how the container model works with the Linux operating system, because everything runs directly on that kernel. I'm not going to drill into this because I'll be wasting too much time going through this, but there's many reasons, right? There's many benefits, both from a DevOps standpoint as well as an administrator's view of the world. And like I say, I'll be giving you these slides so you can look at that later if that makes sense. One important concept I do want to point out is when you deploy a container, the idea you want to keep in mind is you want one application or one set of resources to be mapped to a single container. So what do I mean by that? When you build an image, perhaps I'm going to deploy a database, you don't want to create a Docker image with 2 databases in it, okay? Because the minute you start doing that, you start hitting obstacles, for example, ports being oversubscribed or overused. When it comes to making changes, which database are you making those changes to, and how are those changes within that container affecting one another? And from the outside view of looking inside at the way you've deployed all of this, it can make things more complicated. So the golden rule is you typically will deploy one application or one application tier with all the pieces it requires to run within a single container. And here's an illustration of packaging that, where you can see we've got a hardware, a physical server and an operating system and multiple application containers running on top of there. The nice thing about them being individual containers is that they are self-contained. They can be moved and plugged and relocated as need be. They can be scaled up or scaled down if you're running in a serverless model, for example. There's so many components that Docker is bringing to the table of helping these individual containers be more manageable as one. There's many benefits in deploying in this model, right? So let's talk about more about where Oracle and Docker sit and what does that bring to the table. Now keep in mind, this is not just focusing on the Oracle database. Oracle has a much bigger footprint when it comes to working in this area. So Oracle joined the Open Container Initiative back in 2015, and basically it means that we have some say in developing the solution and helping it with taking into account the core components of the solution and offering that makes sense to Oracle, that we also understand our customers can benefit from. And it means that we're not working in a vacuum, and the requirements we have are being shared and being leveraged by other Docker consumers. So getting back to the database then, so Oracle Linux 7, 3, and later is what's required to run an Oracle database, and that's from a support standpoint. And Red Hat Linux 7, Enterprise Linux 7 or higher. RAC is now supported. That's as of a week or two ago. We now support RAC. But one caveat with supporting RAC is that we're fairly strict about it. It's for dev and test only. It's not for a production workload. Okay? We're not yet at that point. And there's reasons why you would want to take into consideration why you would want to use Docker with a RAC database. And also setting up RAC, there are some quirks. So I'll be demonstrating to you how easy it is to deploy a single instance database. When you go to deploy a RAC database, it's going to be a bit more trickier to perform that operation. Maria Colgan has a blog, SQL Maria, if anyone has heard of that. She has a nice entry in there that steps through the process of deploying a rack cluster in Docker. And you'll see there are 3 main steps you have to do. You've got to go through GitHub. You've got to physically follow the recipe and the instructions to pull down the bits you require. And depending how you're going to run this, if you're running a rack cluster on a single machine, for example, as 2 separate containers on a single machine, you'll have to create one container as a connection manager to help with the ports for the public and private networks. Then you'll have to create another container to be your shared storage that ASM and the OCR and the voting disks, all that stuff is going to sit on, unless you can point to a physical shared storage device that might be running NTFS or something like that. And then you've got to create a container with your grid infrastructure layer, and then you'd run your rack on top of that. So there are more steps to perform the operation, but once it's built, and it can be easily redeployed. So that's the rack aspect. Getting back to the database, it's database versions 12.102 and higher. That's required. And most importantly, the images are available pre-built and ready to deploy on the Oracle Container Registry. So all the legwork is done for you, and it's a very easy way to go forward. Now, keep in mind, when we provide a pre-built image for you, there are going to be limitations, right? And what I mean by limitations is we've determined the block size, we've determined the character set, we've determined the name of the Oracle instance, for example. So if you have some customizations you want to make and you choose not to go down that path, then yeah, we have GitHub repositories that have recipes and all the components you would need to build your own custom images, and that way you can stay on top of it. But if you just want to have a taste and a feel for what it's like to run and manage an Oracle database on Docker, I strongly suggest you go to the container registry and go down that path of deploying it. So I have to say something else here, and that's multi-tenancy. I guess, hands up who in the room has heard of Oracle multi-tenancy option for the database? Okay, a few of you, but not as many as I would have anticipated. So in a nutshell, this whole container model I've talked about at the operating system is the same thing with a multi-tenant database. We have this container database that individual pluggable databases sit within. The security is managed for you, the isolation is managed for you, you can manage the entire container database as one, you can back it up as one, but you can restore individual pluggable databases. You can clone individual pluggable databases, you can unplug them, provision them in and plug them into another container database. You can do all those operations much as you would do with Docker as an image, but at the database level. Now, why this is important is, as I mentioned, with Docker, there's this whole non-persistence model, right, of performing, of just the way the images work. Well, if you've got a dev and test environment and you are looking at having a set of dev work being done against one database, perhaps you're a microservices shop and your developers are very fond of creating an individual isolated database to point that application tier to, right, which is quite common. At that point, why not give them a pluggable database for their individual microservice to talk to? Meanwhile, you can run a container database that contains multiple pluggable databases that each microservice can be talking to. Now, as a DBA or as an administrator, or even as a DevOps person, you've got a single database to patch, a single database to secure, a single database to back up and perform all those operations. Meanwhile, those developers who may be wanting to have a sandbox to quickly do their work and spin up an environment and perform whatever operations they want, can do that within the confines of a pluggable database. So when you pull down one of these Docker images, the Oracle database, for example, it's pre-built as a single tenant container database. So it's, all the building blocks are already there, and there's no reason for your developers to resist, I guess, would be one way of putting it. And for those of you who are developers, it means that you have this environment already built for you, and you can build your workloads, point to the Oracle database, knowing that you can take this pluggable database out of the container and apply it somewhere else. Perhaps you want to plug it into the Oracle Cloud, do a lift and shift. All the building blocks are there for you, okay? And really, I just jumped ahead. That was what my next slide was going to mention. Oh, and actually, that's a good point I forgot to mention, was that plugging and moving and relocating these pluggable databases, it's bidirectional. So a developer is not locked into one particular path, that once they've put their data into this pluggable database running in this environment, that they're locked there and they have to try and figure out how to grab that data from that volume or that physical location, or once they've moved it to a cloud location, they're not locked in there. And in fact, pluggable databases make that model much more easier and much more transportable, so to speak. So talking about Oracle on GitHub, yeah, we have dozens and dozens of recipes and samples and projects and pre-built software out there for you to download. Last time I looked, there was over 1,000 different components. So keep in mind, Oracle's got a rich portfolio of software solutions, right? From database standpoint, we've got the RDBMS as well as the Real Application Cluster Database. We've got MySQL. We've got NoSQL. We've got big data components, Cassandra, if you want to use that terminology. We have many different ways of storing your data. From an application standpoint, I mean, we've got the Java components. We have some of our other software suite components as well that can be leveraged in this model. And the URL is there as well, github.com/Oracle Docker images, and you'll see a whole bunch there from security, etc., on up. Looking at the Oracle database on Docker, if you were to search for that. And in addition to that, we also have, I guess one thing I did want to point out, when it comes to using Oracle software, and you've probably already seen this, when you go to use a component of Oracle's, we often direct you to OTN, or Oracle Technology Network, or oracle.com to download the software, and you have to accept an export and compliance, acknowledge that you've obliged by, that you're following the procedure before you can download something. So because of that, because of those requirements, on GitHub we don't post any binaries. We have all the recipes and all the components, but you would then be required to grab the Oracle binaries and software bits from OTN or from oracle.com to actually deploy against. So we don't have any proprietary stuff listed up there available for download. Now, if you go to hub.oracle.com, this is where you'll find actual images and things that we're providing, and that's you're not going to find the Oracle database there. You're going to find other software components that we provide as part of our suite. Now, the next one is the Docker store. So if you go to store.docker.com and then search on Oracle, you'll see the various pieces that are available to help you get started there. And once again, it appears as though we have the database, but you have to go in and point to where you need to get that data from. The real sweet spot that I think is of the most value is this next one, and this is the Oracle Container Registry. So this is available it's been developed by our Linux team, and we provide images that are pre-built, whether it's Java, whether it's the Oracle database, whether it's some other web tier. And in order to get software from here, you need to sign in with your Oracle single sign-on or your Oracle account that you would have registered with OTN or the Oracle Cloud or wherever else. And once you sign in, so that's the URL, it's container-registry.oracle.com. Once you sign in, it will lead you to a page where we list all the various container services that are available for download, the images that are available to you. You'll see the database, there's Java, there's some Node.js, some NoSQL, operating systems, OpenStack, etc. And if you click on the database, it's going to bring up 3 different database images that you can download. The 3 images are Oracle Database Enterprise Edition, Oracle Database Standard Edition, and Oracle Enterprise Edition Slim. So what our team has done that have posted this up there is they've gone through and they've taken an Enterprise Edition database and removed many of the additional software components, such as the sample schemas, not sample schemas, the startup databases, the seed databases, and extra pieces that are not necessary. So it's a strip down. It doesn't have spatial, for example. It actually doesn't include Apex. That's a fairly hefty one. So if you want to do application express development, then you would want to use the full-blown EE or standard. You would not want to use the Slim. But in doing so, we've given you a smaller footprint. You can see the Slim is 2 gigabytes versus the Enterprise, which is going to be 3 or 5 gigabytes, depending on which pieces you're going with. And you'll also notice we've got different versions of the database available for you as well. Now, this is where my safe harbor statement comes into play. Another image that is well worth considering when you are looking at going down this path is Oracle XE, 18C XE is planned to be released fairly soon. And when I say fairly soon, sometime this year. But we are planning on releasing that, and that will be a fully functioning community edition, if you wish, of the database with some restrictions on the size and the memory, etc. If you're familiar with XE from 11G, it's the same thing that we're rolling out. So let's look at the steps to deploy Docker and a database as a Docker container. The first thing you want to do is install Docker, and this is all running on Oracle software, so Oracle Linux 7.4. You'll want to go in and do a wget for the repo here, the yum repo for OL7, and then you'll go in and actually modify that file, and you'll see there's 2 new entries when you get that repository file that you'll need to modify, and that's for OL7 latest. Actually, there's 3, and UEK, which is the Unbreakable Enterprise Kernel Release 4, and the OL7 add-ons. So under those sub-components, you want to go in and change enabled equals 1. Once you do that, it now expands what's available for you to get from Yum, right? So first of all, you can get your pre-install for the database. Obviously, you can get the Docker engine as well. So at this point, the next step is just Yum install Docker engine. This whole process has probably taken us 5 to 15 minutes, depending how fast you can type. Once we do that, we do a systemctl start Docker, enable Docker, and then a status just to make sure everything looks like it should be running. And then once you've done that, then we'll go ahead and install the Oracle RDBMS Server 12c Release 1 pre-install, which just ensures that your kernel settings and your operating system is configured to run a database. And then this isn't mandatory, but it's a great idea to go ahead and create an Oracle user and a oinstall group. So the steps are there. And set SE Linux to permissive. And once you've done all of this, you reboot the server. I've just put reboot there because, yeah, we're going to restart the whole environment. And then once it's up, you should, well, we'll go in and then set the, we're basically giving Docker running rights. We're allowing the Oracle user to have sudo as rights to run the Docker operations. If you don't do this, then everything you do as Docker is going to be run as root. And talking about the file systems, kind of going back to that whole conversation, if you don't do this, when you pull in an image and you deploy an Oracle database, guess who's going to own those files, those data files? The root user. So this is an important step. When you're going to deploy a database, make sure you give the Oracle user, who is the same user you're going to use to create your database, etc., the rights to run Docker. So at this point, we're just going to go ahead and SU as Oracle. Now, I've actually done screenshots for pulling the image, and the reason for that is over Wi-Fi, this is fairly slow. It takes about 2 hours to pull down this 2 gig or 3 gig file onto your image. Now, if you're running in the Oracle Cloud, well, guess where that Oracle registry is? It's actually sitting in our OCI cloud. So if you're running in our cloud, you can pull it down, I've been told, in about 4 or 5 minutes. because the bandwidth is so fast. So if you're running this footprint as a compute instance that you've created in our public cloud, this will happen very fast. I wasn't confident with relying on that with hotel networks, etc. So I've just got some screenshots. That's the syntax. We simply say docker pull container registry.oracle.com, and here we're naming that actual image. Now, before we can get to this stage, we need to have gone into that website. You may recall the one that was container-registry.oracle.com that was hosted by the Linux developers, and I clicked on there and I showed you the database editions. You need to go there and say, hey, you know what, I think I'm going to download this one. Click on it, and it will bring up that screen that you have to check the box to say, yes, I know that I am taking this software and I'm not going to use it for any bad purposes, right? You do that for whichever versions you want. In my case, I went ahead and checked them all. So once you've done that, you can now type this pull command, okay? Now the very next thing it's going to do is it is going to ask you, actually, I'm sorry, I stepped ahead of myself here. Before you do the pull command, you need to log into the container registry. I'm sorry, I wasn't even looking at my own slide. So you do that login command through Docker, and it logs you into the container registry to associate your account and to know that you've already gone in and accepted those rights, right? Then you type the pull command, and it pulls it down. And here you'll see it pulls down 4 or 5 files. A couple of them are very small in size. There's one there that's 81 meg. That happens fairly quickly. And as it goes through, it runs a couple in parallel, so it doesn't take forever. As it goes through, it starts pulling them down. And then you'll get to the point where it will finally complete, and you'll have this image there, okay? So now we've added this image to our Docker library, so to speak, on our local system. So let me jump in and do something live rather than just screens, and I will switch to sharing my screen so I don't have to apply. You should see the same as what I see. Yep. Keep changes. So here I've got a VirtualBox image running. Hopefully the screen will refresh. Here we go. So this is when the demo gods are going to step in and hit me over the head, right? As I've seen some other demos go today. So the first thing is I pulled that Docker image down, right? So now I can type Docker images, and I can see what's there. There's that image that I pulled down, that slim version of the software. I can also go ahead and say Docker ps-a, and that's going to show me what's running right now. Now I happen to have one that I've downloaded several times. I downloaded some time ago, 3 weeks ago, and I've done some things with it. You can see the last time I ran it was about an hour ago. So now I'm going to go ahead and create a completely new Docker container to run in. And because I'm bad at typing, I've got another window here that has my command, and that's it there. So I'm going to say Docker run dit. So dit means it means interactive, but then D also means in the background. So I'm combining both, and I believe there are benefits in doing that. Every example I've looked in our blogs are using all 3 of those switches together. And then I'm giving it a name. So I'm going to call it code-boston, and that simply just means that's the handle, if you wish, that I'm going to use to run this container with. And then if I want, I can map those ports. If you don't do that, it's just going to map 1521 to if it's available, it will just be natively 1521. It's a good practice to map the container and the local system to be the same. So we're doing 1521:1521. If you'll often see there'll be another -p 5500:5500 for Enterprise Manager. And then the next thing you should typically see, which I've skipped, is a -v command for the volume where you want to mount those data files. Now I'm being lazy and I'm just trying to show you the easiest way to do this, and then you specify the container image that was in that. When I did the Docker images, this is the image that I'm actually going to run. So I'll go ahead and hit that, and it's going to kick off, and it gives it this cryptic key that I can now use to map things with. But more importantly, if I now do a docker ps -a, you'll see our new image called, or our new container, I should say, called, where is it? I'm looking for the name. Here it is. Code Boston is the top one, and it says it's starting. So it's actually creating this container that I can now run, okay, and execute against. Now, we could just sit here and wait. It's going to happen pretty quickly, probably about 5 minutes. We'll have this database up and running. But if you're like me and you're inquisitive as to what's really going on, you can type docker logs, and I believe I need to put code-boston as my image name, and you can see what's going on. So it's actually at this stage just running a couple of operations, and you can see it's untarring something right now. It's actually taking this file and untarring this 2 gig file to be this directory that will be created. And if we follow it for a little longer, you'll see it cycle through these log files as it goes through. Come on. I probably should have kicked it off while I was talking. So Docker is the operations, all the commands we run will be through that Docker syntax, right? And that's why we give the sudo as rights to Oracle and allow Oracle to run that Docker program. Now, once the image is running, we can run it, we can connect to it, we can run a workload against it, we can stop it, we can start it, we can perform all those operations. From the standpoint of running the ps command, one of the mistakes I always make is I forget to type Docker because it's so native in how it behaves. At this point I can see it's still starting, and you can see it's been up for 2 minutes, but it's still not actually available for us. But in doing the create command, the image will be instantiated and I will be able to connect to it. Now, if I want, once I've finished doing my testing and I want to quit what I'm doing but not destroy everything, just keep it safe and sound and come back to it another day, I can simply say docker stop code-boston, and that will bring that image down. Now, the very first time you start it, it is taking longer than it will normally take. I could demonstrate that, in fact, by starting up the ORCL Docker one. You'll see that will start in 4 minutes, because that image is already unzipped, it's untarred, it's created, it's laid down all the files. The very first time you do that, it's actually laying everything down. And let me just check now and see that log file, and I can show you where it's at. So you can see it's moved along. It's actually gone ahead and done some port mapping. It's gone ahead and created it's creating ORCL PDB1 as part of a container database. It says the database is ready for use, so that's good. I actually thought there would be more to it, but that's good. And if we want to do a ps -a, we can see it will tell us, oh yes, up 3 minutes and healthy. So it's actually started. So at this point, there's two things we can do, right? We can actually log into it and log into it as if we hadn't have done the interactive mode, we would actually be running inside that window. But it becomes a bit tricky to work with once you're done with it, right? It's similar to running a shell command in Unix or Linux where you run it in the background. You can kind of see what's going on, but it's a bit quirky to get to. If you do the interactive mode like this, it's running and we can connect into it. So let me type a SQL plus set operation. I think I've got one in my history here. Oh, and by the way, and it's in those notes. So when I went to, let me just pull that up, the container registry site, I'll sign in just to show you what it looks like real time. There's a lot of good information here that I would recommend logging in to check out. Don't need that. Come on. Oh, good. I was hoping it wasn't going to text me a code. But if you click on this and actually click on the different versions, one of the points, important pieces of information here, there's a lot of great data, is the fact that the password is listed here And you'll see that because this is a pre-built image, right? You can go in and change that password, but yeah, if you want to connect to sys, you'll need that password. You'll see it's 0RA_doc_db1. But all of that information is there. Yep, 0RA_doc_db1. And then it also gives you some other information about what pieces are not there in the Slim build. For example, where is it? Oh, I didn't go to Slim. I went to Enterprise. Let me go back. Pick. Oh, that's strange. I was in the right one. So somewhere over here, it will list what's missing from this. Ah, here it is. It says it has doesn't have support for analytics, Oracle R, and label security, text. Oh, it's grown, and Application Express. So it's missing some of the core pieces that we don't think every user is looking for. So yeah, let's get back to actually trying to connect to this database that's running there. Here's an example. So here I'm going to go in as sys, using that password, and I'm using the default CDB. Oops, helps if I hit enter, and I'm in there now. You can see the PDBs that are running. I can say alter session set container if I like, and I can connect into that PDB. I can also say exec dbms pdb.describe. Does anyone know what this is doing? What I'm actually doing here is generating that manifest file for that PDB. So I can say, yeah, I want to call it mani.xml. Hopefully my typing is right. orclpdb1. And it's generated that manifest file. Now what I can do now that I've created this manifest file of my image, if I'm the DBA or the developer who wants to take this and use it somewhere else, is when I'm actually done with my image or I've done whatever testing I wanted to do, the way I can get rid of what I've got, first of all I can say docker stop code-boston. It will come up with that name. You should see that in a moment. And now, it used to happen like that, but we've changed it so that there's a bit of a lag, and the reason for that is we're shutting down the database cleanly. It would be, you would have to work around it in the past. You would have to say stop -T30, for example, and then what the name of the image was, which is saying wait 30 seconds so you could gracefully bring everything down. By doing it this way, it's clean and it's ready to go. If we do a docker ps-a, you can see that its status is now exited as well. Now, just to show you how quick it is to start up, I'll pick the other one, for example, docker start orcl docker. You'll see it comes up fairly quickly. It was just that first time we instantiated it that it took a little while. So it's going to say it's starting. It's currently been 4 seconds. 13 seconds, it's still starting. It'll take about a minute on my system with the configuration that I have. Keep in mind I'm running VirtualBox on a laptop that has other things running. But yeah, in a minute or so, my system will be available. Now, getting back to the other database that I created and we were using, and I mentioned I created a manifest file. When I'm ready to get rid of it and free up that space, one command I can run is docker rm. So I'm going to remove that container completely from my system. Now, if I just said rm code-boston, what it will do is simply go in and drop the image, but keep those files there. Because remember when I installed this, I set it up so that it's running as a separate volume because this is a database, and I want those objects to be persistent. So if I say remove code-boston, what it's going to do is remove the container, the instance of it, and remove it from my Docker registry and everything else that's local to this machine, so to speak, the library. But the files, the data files will still be there. Now that's a good thing, right? Because now I can come along, I've got my PDB manifest file, and I've got those data files. I've now got the pieces I need to unplug and plug if I want to use it in that way. I'm not saying you have to do it that way, but it's just one of the benefits. but I'm going to just do a clean remove so that I'll free up some disk space. Oops, did I call it? No such container. Oh, I see, sorry. Typo. PS-A. And now you can see I've only got one container there now. And by the way, it's up. It's been up for 2 minutes, and it's healthy. And I could connect to that database if I wish to. Now, how am I for time? I think I've run out of time. I've got more content to talk about. I'll mention it rather than show you slides, so I'll be quick. What I'm showing you is creating your own Docker images and doing everything yourself, granted with pulling these images from the container registry. But Oracle has other solutions. So I mentioned you could do this really quickly, go into Oracle Cloud, use those $500 credits, create a machine, a compute, install Docker on it. The steps are really straightforward. Install a database, you're ready to rock and roll. So that's one way to do it yourself, homegrown. The next one we have is the application container service. And then we have the container service itself, cloud service. The application container service provides pre-built images for all the pieces you would want to build. Just like how I have the Oracle database as an image, all those working pieces would be there. And then the final one, actually, yeah, all the working pieces to have the load balancers, whatever. And then the final one is where we provide a complete suite of services around deploying and managing the CI, the CD, the CD, right? All those pieces are there for you to have lifecycle management, to understand how your containers are using your resources. So that's it. I apologize if I ran over time. There was more to go through. But anyway. So thank you.